This is video number 1 for section 8.5, How to Solve a Rational Equation. So we have been looking at rational expressions in chapter 8, and now we come to this idea of a rational equation. A rational equation just means an equation to solve, so it has an equal sign. And inside the equation, you're going to find some of these rational expressions, some of these algebraic fractions that we have been looking at. Well, solving an equation just means the same thing it's always meant, which is figure out the value of x that makes the equation true. And the thing is, the overall strategy here is really not that different than what we've done in the past. Anytime we've had an equation that has fractions in it, our strategy is clear the fractions. This is going to be a little messier, but really it is just that same strategy. I've given you a box here with a set of instructions to follow, and so let me demo the steps here on this sample equation. If I want to clear the fractions, again, we've done this in the past, the first step is to find the LCD, the lowest common denominator. We've been practicing this a lot already in chapter 8. It's the whole grocery list thing, right? Factor the denominators. These guys already are 3 times x, and for each factor, just take each one the most times it ever shows up in any one place. So let's see, as far as the numbers, as long as I take a 3, I'm covered. And nobody needs more than 1x, so as long as I take 1x, I'm all set there as well. Now, in the last couple of lessons, we've been taking the LCD so that we could change the denominators and add the fractions. That is not what we're doing here. The goal is not to add fractions. The goal is to destroy the fractions. I don't want to have the fractions anymore, and I can do that because I have an equal sign. I'm allowed to do the same thing to both sides of the equation. What I'm going to choose to do is to multiply both sides by that LCD. That's what step 2 says. So the left side and the right side. I would really suggest, honestly, that instead of just writing it kind of once on each side, that you actually physically write it next to each term you're going to multiply. In other words, rewrite the equation, maybe spread things out a little bit more than they were, and leave yourself room so that next to each item, next to each term, you can actually write times 3x over 1, times 3x over 1, times 3x over 1, or maybe here I don't really need the over 1. The advantage of this is now you can physically slash out, right, the common factors, because that's what we're going to do next. We're going to divide out the common factors. For example, here, the 3's drop out and the x's drop out. Awesome. On this guy, it would be the x's that are in common. And of course, there are no fractions over here on the right side. If you look across the bottom here, there's no fractions anymore. I just got rid of all the denominators. If that doesn't happen, you have made a mistake. Let's put together the pieces now. All this stuff just turned into 1s, so the only thing I have here is just that x plus 2. The second guy, let's see, just the 3, I believe, is left there. And the right-hand side, 2 times 3x is 6x. Step 3 says, now go ahead and solve the equation that you get. Once the fractions go away, you'll either have a nice, simple, linear equation like we did in chapters 1, 2, and 3, or you'll have a quadratic equation like we did in chapters 6 and 7. This is just an easy guy. So you got a couple of like terms to add up. And then, let's see, maybe subtract the x from both sides. Divide by 5. And it looks like I'm ending up here with x equals 1. Now, here is perhaps the most annoying part of the whole thing. We haven't really had this happen to us all semester, but remember that rational expressions have potential domain problems, those bad x's where you can't stick it in because you make a 0 in the bottom. It is possible to do all your algebra right and come down here and get an answer, but it's a bad answer. It's an answer that you can't stick in. And so what step 4 here is saying is at the end of the problem, you don't have to necessarily run a full check, but you at least need to go back up to your original equation and make sure that 1 isn't a bad x. Make sure that it's an okay x, that it's defined. So let's try that out. If I plug 1 in, it's just the bottoms I'm worrying about. 3 times 1 is 3, no problem. If I plug 1 in here, I just get 1, no problem. Then I can go ahead and put a box around my answer. The answer is x equals 1. If 1 was a bad x, I'd have to throw it out and say, sorry, there's just no solution to this equation. Another way you could go is at the very beginning of the problem, you could take a look at your denominators and you could say, well, let's see what bad x's might come up in this problem. And I think it's just 1 here, right? The only x that would make a 0 in the bottom is 0 itself. If you try to plug 0 in, that would be bad. So you could jot down something like that at the beginning, or you can just look at it after you solve the equation. On the next video, I'll work a couple more examples of this process.